Hello everyone, welcome back to class again. How are you doing? I believe you are all doing fine. Today we are still going to continue from where we stopped last week. Isomerism of alkane. When we say isomerism, isomerism is a phenomenon whereby a compound, one or more compounds, have the same chemical formula but different chemical structure. It means that they have the same number of carbon atoms, they have the same number of hydrogen atoms, but their structure is quite different. Now, let me give you an example of butane. How many carbon atoms is butane again? But yes, it is 4 carbon atoms. So let's draw it. 4 carbon atom, then you put your hydrogen around it. Very good. This is butane. Okay, this is the normal butane, we call it N-butane. Now, we also have another one. I can decide to carry this CH3, C here, and the O3, the hydrogen, the 3 hydrogen, and put it under this. If I do that, what will I have? I will have something like this. Remember, I'm going to carry this under this. So it's going to be like this. Now this is no more butane, but another compound. Now let's count the number of carbon atoms in butane. 1, 2, 3, 4. We have C4, right? Let's count the number of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our hydrogen is 10. C4H10. Am I right? So let's go down here. You can see that the structure is quite different. But let's look at the number of carbon and also the number of hydrogen atom that is there. 1, 2, 3, 4. We still have 4 carbon. Then let's count the number of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is still C4H10. Both of them, they have the same chemical formula but different chemical structure. Now for this one, it is called 2-methyl propane, or we can also call it isobutane. Isobutane. That is an example of isomerism of alkane. Let me give you another one example more before we move on to another thing. I'm going to give you that of pentane. We call it isomers. I'm going to give you that of pentane. The isomers of pentane. Now pentane, pent means 5. So pentane is a 5 carbon atom compound that has hydrogen around it. Yeah, this is pentane. Pentane. So this is pentane. Now let's now look at the isomers of pentane. Now I'm going to still do it this way. Let me first of all carry this CH3 and put it under here. If I put it under there, what do we have? We have C1, C2, C3, C4. Then I'm putting it under here. So I've carried the last carbon and hydrogen here. Then the remaining one will be like the way they are. So it's going to be like this. This, and this. So let's count. 1, 2, 3, 4, 5. C5 right? Let's count the number of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See 5, 8, 12 for the pentane. So let's count this one too. 1, 2, 3, 4, 5. See 5 again. The number of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See 5, 8, 12 again. But this is going to be 2-methyl butane, or isopentane. Now this is one isomer of pentane. We can also have another isomer of pentane. How? We can decide to also carry a CH3 that is here and put it on top of where the CH3 was before. How? Look at it. So now it's going to be 3 carbon like that. Then this is going to have a CH3 and it's also going to have a CH3 here. Then we put our hydrogen. Hydrogen, 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 and another hydrogen. So let's count. 1, 2, 3, 4, 5. We have 5 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12. So when you look at it, this is called 2,2-dimethylpropane, or we can also call it neopentane. So when you look at it, they have the same chemical formula but different structure. So these are the isomers of pentane. So that is that about that for this class. Next class we are going to look at alkenes, then also how to name an organic compound.